So, amending what I mentioned yesterday, so I told you that the degrees of freedom was n minus 1, where n is the number of variables, essentially, so number of variables. So, in the standard chi-square goodness of fit test, it is the case, but you have to consider the distribution you're using. So, I'm going to go into what degrees of freedom are, because it's much easier on a contingency table to show it. But essentially, if I've got an equation, so x plus y equals 3, I would say there is 1 degree of freedom there. In that equation has 1 degree of freedom. So the idea is, how many variables do you need such that you can find every variable? So do you agree I need one of them, and then I can find everything? Do I need 2 variables to find both of them? So I need there's 1 degree of freedom there. How many degrees of freedom does this equation have? 2, yeah. So if I know 2 of the variables, I can find all of them, right? So hence, when we were looking at this yesterday, it was, what was it, number of goals, or whatever it was, number of goals and frequency. So if I'm told the total, so say the total is 100, and it's 0, 1, 2, 3, and it's 10, 20, 30, and then this one's missing, do you agree I could find it? So I only need to know 3 of them out of 4. So this would be 3 degrees of freedom. That's essentially what the idea of degrees of freedom is. But because we're working from a distribution, so if we were working with binomial, so what we were doing yesterday was we were testing if a distribution fit. So let's say x is distributed to binomial of 10 trials, and I assume it's 0.2. So there are 2 parameters there that you don't necessarily know, but based on what you know, you actually know n usually, right? You will always know n, so n is the number of trials. But do you agree that what you're working on is you're assuming that this is 0.2? That's essentially an extra assumption, an extra variable, so you take 1 more off, essentially. So when we did the first question we did with the archaeological site, we didn't do that at all. Why? Because what distribution was it?
Uniform?
It was a uniform distribution, yeah. And how many variables, how many parameters are there for uniform? None, there aren't any, just 2 numbers. So there's no, so the binomial one we did, and then what about the Poisson one we did? So x distributed, how many parameters does Poisson have that we are assuming? The mean, right, lambda, we assume it, right? So yeah, that's an extra parameter. So formally, the degrees of freedom is equal to n minus 1 minus number of assumed parameters. So that quite literally only applies to what we did yesterday. Here it will be completely different, so completely separate, okay? So chi-square contingency tables, and I will warn you, these questions are quite big, and you are going to need a full page for each one. These do get quite involved. So, Chinese, Indian, Mexican, and then Thai. Is Thai spelled Thai?
Yeah.
Yeah, I thought so. And then, so Chinese, and I will write all Indian, Mexican, Thai. So, this is going to be nationality versus favourite food. So, does anyone remember 2-way tables from year 8? No? Okay, I'll give you an example of a 2-way table. So if I said to you, male, female, football, basketball. So in a class of however many people, and then we have a total in this axis, and we have a total in this axis. So if I said to you, so if I said to you, 20 men want to play football, and 30 of them want to play basketball, and we have that 25 girls want to play football and 15 of them want to play basketball. So from this, do you agree we can work out the totals of each of these and then the grand total? Do you remember this from GCSE? Really vaguely, maybe, from a while back, yeah. So 45 people want to play football, 20 of them are men, 25 are female. And then there are 45 people that want to play basketball, and 15 of them are women and 30 of them are men. How many men are there in total? There are 50. And how many women are there in total? 40. Do you see that both of these, regardless of how I count them, the grand total will be the same? Yeah. So similar here. So what we use here, so you're going to be given a 2-way table. like so. So this is, I asked people of different nationalities what their favourite takeaway is. So I've asked Chinese people, Indian people, Mexican people and Thai people. So what their favourite type of food is, or what their favourite, and realistically it's going to be a bit biased, right? So what you are testing is you are testing independence. So this would be nationality, and this can be food. So your H0 is simply going to be favourite food and nationality. So what do we reckon? So the null hypothesis is usually the boring option. So am I going to say that they are independent or not independent? So is there a relationship or is there not? So the boring option is usually there's no relationship, right? So the boring option would be they are independent. So the favourite food and nationality are independent. And H1 is that favourite food and nationality are not independent. So note that because you're rejecting H0, it doesn't assume there is one, but you can't say that they're not independent, so they're not necessarily the same thing. Right, so let me add some data and let's go through this. So actually I will just use my data from earlier. So, like I said, these get quite big quite quickly. So I'm going to use the word sum because I've already used T for Thai, okay? So I'm going to use sum instead of total, but generally speaking it will use a total. So I'm going to say 40 Chinese people said they like Chinese food. I'm going to say 10 Chinese people said they like 5 like Mexican, and we're going to have 0 liking Thai. And then we're going to have our Indian people, we're going to have 25 of them said they like Chinese food. We're going to have 80 of them saying that they liked Indian food. We're going to have 15 of them saying they liked Mexican food, and we're going to have 10 of them saying they like Thai food. And then for Mexican people, we're going to say that 5 of them like Chinese food. We're going to have that 20 of them like Indian food, and we're going to have that 40 of them like Mexican food, and we're going to have that 5 of them like Thai food. And then for people that like Thai food, we're going to have 2 of them like Chinese food, 5 of them like Indian food, 4 of them like Mexican food, and we're going to have the 9 of them like Thai food. Actually, I want to make these a bit higher, so we'll have 20. We'll have 20, 15, 14, and 16. So the reason I'm making the values respectively high is because if I go too low, do you agree I'm going to get an estimated value below 5, and I'm going to have to do pooling, and I don't want to do pooling yet in the first example. So that's my two-way table. So this is the sort of thing you'll get. So what can I add? I'll remove the sums. Yes, let's do the sums. So the sums here, so 40, 20, so 50 and 60, so that's 110. And then 90, 110, 125. So 20, 60, and 74. And then 0, 10, 15, 16, so 31, 41. And now let's do my totals up here, so 55, and then 40, 120, 130, yeah. And then 40, 40, 20, 100. And then 30, 35, 65, yeah. So adding these up, so I would say this one's probably easier to add up. So 60 and 60 is 120, and then 230 on top, so 350. Yeah? 350 for the grand total. Yeah. So what I find is this is quite confusing with the amount of stuff here. So I'm going to circle these because what I want to emphasize is they are not part of your actual data set. So when it comes to degrees of freedom, you do not count these. So when it comes to that, so please do not confuse yourself with that. Right, so that's my initial two-way table. So to perform a chi-square goodness of fit test, what do I need? I need the observed, and I need the expected, yeah. So, the way we found the expected is we always assumed the null hypothesis, right? We always assumed that the distribution worked, and then we used the distribution to find them, right? So here, our null hypothesis, I rubbed it off, but our null hypothesis was that they're independent, right? So I want to derive how you would do this logically, okay? So do we agree that there are 350 people surveyed in total? Yeah? So do you agree that 100 people of those 350 are Mexican, right? So do you agree the fraction of people that are Mexican is 100 out of 350, yeah? So that fraction of people should also be, so how can I put this? So it's that fraction of people that are Mexican, right? And we know that in this column here, 110 people pick Chinese. So of the 110 people that pick Chinese, do you agree that this percentage of them would be Mexican? Because so the idea is that this is times 110. And I want you to notice something here. Do you agree it would be the same for every entry? So what have I done? So look at this. So you don't want to do that every time, because do you agree I've got 16 entries? I'm going to have 16 chi-square calculations. It's a lot. So, what was this? It was the row total. And what was this? The column total. And what was this? The grand total. So the estimated value is the column total, column sum, I'll leave right over here, is the column sum times the row sum divided by the grand sum. And that will give you your estimated values for everyone, essentially. So if you want to write that down quickly, and then I can rub it off, because I'm going to need the space to draw another grid, unfortunately. So it's the column total times the row total divided by the grand total. Again, if you ever want me to go over that logic again, I'm quite happy to, but it's not too bad to remember. It's just column total by row total. Right, so Chinese, I'm going to use letters here again now because we know what they mean. Thai and Chinese, Indian, Mexican, Thai. Right, so we do not need our sums because they're not part of it. The sums are just used to calculate the estimates. So, for this entry here then, so do we agree it would be 55 times 110 divided by 350. So 55 times 110 divided by 350. So I get a chi-square value of 17.29. And then let's go to the next entry. So it's 125 times 55 divided by 350. So I get a chi-square value of 19.64. And let's go again. So then Chinese people that like Mexican, so the 5 on the top, so it's 55 times 74 divided by 350. So that is a chi-square value of 11.63. And then Thai people, so on the top right, so 55 times 41 divided by 350. 6.44, and I was a bit nervous about that one being less than 5, to be honest, but I'm glad it wasn't. Let's keep going then. So tell you what we can do. So there's 3 rows left to do. So I'll do 1 row, you 3 do this row, and you 3 want to do the bottom row, just to save time. So I will work across this one. So you 3 over there do the Mexican row, and you 3 do the Thai row. So just write them in your one, and then you can just tell me them, and I can put them on my board, and everyone can have them. So. I've done, but I'll start doing the other ones and see if yours match mine. They should do. So it's the column total times the row total divided by the grand total. So this one here should be 110 times by 100 divided by 350.
Well, I've got that one as
110 times.
Oh,
Oh, rather, yeah, 31.42. Yeah, I got it wrong. Thank you.
sorry, I was confused.
Sorry? Yeah, 31.42. Okay, so any of you finished your calculations yet then? So can someone tell me about, if you three are done, can tell me about. And you can all corroborate this, make sure everyone's right. So go on, yeah. 21.
13.74.
Yeah. 7.61. Okay, you three, you go through these.
Yeah,
So,
next
okay.
one is 35.71.
Yeah.
Then it's 21 point, oh, what have I written that as? 1.14. And then the last one is, yeah.
Looks the same as the one I did. Have I done the, hang on, 125. Let me redo one of my rows a sec. So my row should have been 74 times 130 divided by 350. So my row is, oh, I'm wrong, great. So 27.49. And then let me just double check my last one. So 41 times 130 divided by 350. 15.22. Okay. Right, so these are our estimated values. So now can we perform the chi-square test?
There's one more, the first one.
On my row?
Yeah, that first one there is 40.86.
See, I'm just blind to this sort of thing. It's why I circled the sums, because I get these wrong every time I do them. I know what to do, I'm just stupid. Yeah, 40.86, thank you. So 40.86. And we may as well check the other one out on that row that I did, which was 125 times 130 divided by 350. That one's fine. Right, okay, so we've got our estimated values and we've got our observed values. So now do you agree we perform our chi-square test? Yes. Yeah. So our chi-square value, so where you are, well, I give you the choice. What they will do on the exam usually is a third two-way table, essentially. So CIMT, CIMT. And essentially you just perform the chi-square calculation. So remember, observed minus expected squared, and then divide by expected. So I'm happy to work on the top row. So for example, I'm going to be doing 40, take away 17.29, squaring it, and then dividing by 17.29. And you've got to do it for every entry. It's quite a bit, yeah. Yeah, so you want to take the same rows, leave the second row, I'll do two rows. So yeah, they should be. You want small values. Unfortunately, some of them are going to be big.
If it's smaller, does it mean it's less error?
Yeah, exactly. You want the least error. You want the least error possible, really. So usually certain values give you larger error, essentially. So the next one then being 80 take away. So you'll be happy to know that the exam doesn't require you to do all this usually. Usually it'll be written out for you and there'll be one or two missing values that you will have to find. They will not make you do all of them. But formally, if you are a statistician, this is the chi-square test you do. And if you're a statistician, you don't even do it by hand. You literally do this in Excel and you click 2 buttons. Microsoft Excel can do this in seconds. Right, so 15 minus. .67, and then so 10 minus 15.22 squared divided by 15.22, 1.79. Okay, how's everyone else looking with their rows? Okay, so can I have the bottom row then, Yassine?
9.05 times 10 to the minus 3.
Okay.
And then
Hang on, 9.05 times 10 to the minus 3. Okay, so 0.00905, so 1, 2, 3. Yeah. Okay, go on. And then what's next?
2.9.
Sorry?
2.9.
2.9, sure. Next one. What's it with you? You said? And then last one. 9.2.
Oh, just 5.
Okay, you got the Mexican row.
Yeah, 1.315.
Sorry?
1.315.
1.315.
6.911.
911, yeah.
16.83.
0.83.
0.924.
0.924. Okay, perfect. Okay, we're almost done. So remembering what our H naught is, so H naught, so nationality and food are independent. And there will always be a test for independence with the contingency table. Nationality and food are not independent. Okay, so we now need to state our rejection condition. So reject H naught if chi-square value exceeds the chi-square critical value. So what we need, do we agree, and we'll go for the 5% significance level at 5%. So what we need now is our degrees of freedom. Anyone got any ideas how we find the degrees of freedom from a contingency table? You're not going to guess this, I don't know why I'm asking. So essentially, how many is it down this column? 4. So 3 degrees of freedom on this one. And how many is it across? 4. So 3 degrees of freedom there. So 3 times 3. So 9. So you n minus 1 here, n minus 1 here, times them together. So do not include the total column. I've done that many a time. Do not include the total column. That does not count as a variable. So the critical value with 9 degrees of freedom at the 5% level. So we want to go to our table. So we're looking for 9 degrees of freedom at the 5% level. $16.919. So chi-square critical value of 9 degrees of freedom is 16.919. Okay, so I'll be honest with you, you can see from entries like this that we are absolutely going to pass that threshold. You can see that we are. So let's calculate our chi-square, our actual chi-square value. So do we agree we've just got to add all these up? Which again is fun, right? We should all do it together, just make sure we all get the same thing. So like I said, they are never going to make you do a full one from a full table, but they will give you elements that are missing.
Wait, you have to add every single one.
Yeah, so these are all chi-square statistics, you've got to add them all up. This was 0 point, just to be clear, oh, this was yours, wasn't it? Was this 0? This was just 0.91. Say was 6, okay, thank you. Yeah, more clear. Okay, so I get the chi-square critical, our chi-square value to be 120.814.
Yeah.
Yep, good. So let's now comment on our findings then. So we reject H naught if the chi-square critical value at 5%, if the chi-square critical value exceeds that. So it absolutely does exceed 16.919. So we reject H naught. So reject H naught at 5% level. Insufficient evidence to suggest independence. So notice how I phrase this, right? We have proven that they are not independent, but we haven't proven that they are there is a relationship. There is a difference between saying they're not independent, but there is a relationship. So I'll give you an example. So is this an accurate, I'm going to give you a description of this, right? This is not an elephant. Is it an accurate description? It's correct. Is it accurate? It's not the same as saying actually giving you a useful description, right? So when you say nationality and food choice are independent, are not independent, it doesn't mean that there's necessarily a relationship. It just means that they're not completely isolated from each other. You can't assume that. Right, so I think the best thing here is for me to just give you a question and you have a go at it. So I've got one from the worksheet and one from the exam. Alright, so chi-square contingency table. Worksheet PMT. Right, so this one's nothing terrible. So it is 10 marks. So this one here, you are going to have to do the full 3 tables yourself. But as you can, no, you can't see because I've lost where's my TV remote? So it's under here probably. So as you can see, this one is much smaller. So it will take you far less values. So remember, the estimated values are from column total times row total divided by the grand total. So the first thing you should do, you are going to have 3 tables. It's going to be this one with all your sums, this one with all your estimated values, and then you're going to have one with your chi-square values. If I'm honest, if you want to just calculate the chi-square values and add them up without drawing the 3rd table, you're welcome to. But in the exam, I have seen them draw a table for chi-square values. So a random sample of 100 people were asked if their finances were worse, the same or better this time last year. The sample was split according to their annual income and the results are shown. So test at the 5% significance level whether the state of someone's finances is independent of their income. So like I said, I think you'll agree with me with what I said at the beginning. You are going to need a full page for each of these. You are going to need a reasonable amount of space. So if you do have any questions, do let me know. Yeah, let me move the camera over so I can actually have a go at the question.
Is it parents? My bad.
You got a conclusion? Yeah, or you can say there's no association, or something along those lines. In other hypotheses, we look for the words either independent or association generally. No association or independent. So at the bottom of this worksheet actually is the examiner's comments. And I'm sure you've seen some of these but never actually looked at them. So when an exam comes out, you get the paper, the mark scheme, and you get the examiner's comments. The examiner's comments are quite useful for us because they tell you essentially what people did wrong. So like they'll say question 1, even the weak candidates did really well with this one. Question 2, loads of problems and so on. So you see where the issues were. Do you know what most marks are lost on chi-square? Because I find this procedure is quite procedural. You just go through it, you just go through the motions. It's the conclusion and the hypotheses, yeah. People write the hypotheses the wrong way around. And this book work is just, you gotta learn it. Unfortunately, you've got to learn which way around it is. That's where most of the marks are lost. Another 30 seconds or so. Okay, so did your fail to reject H naught? Yeah, good. So here's the mark scheme. So your expected values should have looked like that. So none of them were below 5, which was nice. And then stated fact, so stating H naught and H1, so state of finances and income are independent, and finances and income are not independent. So these were your chi-square values, so 18.59, 11.48, and so on. And then you should have got your chi-square statistic to be 3.553.
Yeah.
Are we good? Good? Sure. So they should have added to be 3.553. I'm not too bothered about a small numerical mistake, to be honest. I imagine this, if there are any, there probably is what it is. Are we happy why the degrees of freedom is 2?
Yeah.
So it's 3 on this row, which means 2, and there's 2 on this row, which means 1, so 2 times 1, which is 2. Okay, I'm going to show you an actual exam question now. Also, we are pretty much done with stats after this. We've got one more lesson on contextual PDFs, which I want to cover if those come up. So, before we actually have a look at that, let me take you back over here really quickly. So, something that they have been known to ask. Let me just make sure my camera's getting that. Okay, perfect. So, something they have been known to ask is something like this. So I'm going to remove this. I'm going to remove this. And I'm going to remove this. Fill in the gaps. So you've got all 3 tables. How do you fill in the gaps?
The sum of that.
Yeah, we just do that.
Oh right, yeah, that's a fair point, yeah. And this, on the sum, then yes, you can work them out, but let's pretend we don't know the sum. Let's pretend the sum's on there. But yes, you absolutely can, yes. What's another way of doing it? So, to be clear, I've removed different ones here, so these 2 aren't related. So let's go over finding the observed value first, right? So do you agree the chi-square statistic for this cell is 6.16? So do you agree the 6.16 is equal to the observed, the thing we're looking for, minus the expected, which was 40.86? Yep. Squared divided by 40.86. Yeah? So 6.8, the observed, I won't write this as O, I'll write it as X, the thing we're looking for, let's say. So we take this over here, so 40.86 times 616, and then do you agree it's a quadratic? Yeah, so you would solve the quadratic, and you'll get one positive, one negative, and obviously we go for the positive one. Makes sense? You would use your calculator for that quadratic, right? And again, let me just reiterate, you are all happy with using your calculators for quadratics? Yeah. I'll do this one formally, just to kind of go through it. But observed minus, so we're going to have 40.86 times 6.16. So that's going to be 251.696. So 251.6976 equals x squared minus, and then was 40.86 times 2 minus 81.72x plus 1669.53.6. So moving this over, so we get that this is a quadratic of the form, oh well, it looks like this. And you said you can all use your calculators to do this, yeah? So you could also use quadratic formula, which is what I'm going to say.
So is that how do we do on this calculator?
Right, so you know when you press menu, so you know when you go to the function button or whatever to like go for distribution. So if you go, one of them should be called equation,
Oh, okay.
and then you go for polynomial of degree 2, and then you sub in your coefficients. So 1, negative 81.72, and 1417.842.
Interesting. Bien this calculator.
So there are two answers here, which is, so the two answers for x that it gives are 56.72 and 25 exactly. So unfortunately there is giving me a second one that I shouldn't have, but there will be some condition in there that will tell you which one it is. But you get back to it, right? That's the main thing. Okay, so we proved that this is 25. Okay, so how do we now do one like this? How do we find this missing one on the expected values table?
You use 65 plus 4.
Yeah, it's just the expected value, so you can just fill it in, right? Exactly. So whatever it was, so in this case it was 65 times 41, let me go off this mode that I don't like. 65 times 41 divided by 350. So this is 7.61. And now we've got this one here to deal with on the chi-square value table. How do we find that? It's just the chi-square statistic, right? Do you have this one and this one? So it's just the chi-square statistic, right? So 46.34 and 80. The hardest one by far is a missing observed value, as you've just seen. 24.27. Right, so I'm going to give you an actual question from the actual A level, and we'll see what you think. So usually this question is dead last. Usually, chi-square is usually the very last question. Usually. So there we go. Not quite last, but you see what I mean by these three tables? I know it was a lot of work doing it like this, but it's worth it, and that you see how it's crazy. Right, so an online survey on the use of social media asked the following question. do you use any form of social media? And it's the age in years. Hang on. So it's age in years, and it's split into 4 categories, and they very nicely done the total for you. And do you use social media, yes or no? So your first question, state the null and alternative hypothesis for 1 mark. And then part B, they literally give you all the expected values, but it just says, show how the expected value of 228.18 is found. Are we all happy that we could do both of these 1 mark questions? So we state the 1 mark and then explain how you would get 228.18. So in that instance there, that's the top left entry, so it would be 1,266 times 352 divided by 1,953. Easy enough. And then part C, determine the value of S in the table. So note what these are. So this is just the observed values. These are the expected values. And these are the chi-square contributions, right? So how do we find the value of S? I'm actually just going to let you do it. I'll let you do it. Don't say anything. I'll let you do it. So find the chi-square contribution for that cell. Again, that is for 2 marks. So like I said, they will not make you do all of it. It will be filling in bits and pieces to show that you know how to do it, essentially. Okay, so Tristan, what'd you get?
So I'm still trying to work out the last one by myself to get it in my foot.
Yeah, sure, fair enough. Caleb, what'd you get?
14.2.
Yeah, did we all get that? Good. So let's look at the entries then. So the entry we're looking for, the chi-square entry, do we agree it's 30 to 49? Yes. So the expected value is this, and the observed value is this. So it's this, take away this, squared divided by this. So we're just using our 2 tables like we did here. So we use this table and this table to get this table. So the calculation here, if I make some space for myself, is, so the chi-square value, again just to reiterate, we are in the 30 to 49, yes, that's the one we want, so 30 to 49, yes. The expected value is this, the observed value is this, so it is. So the chi-square value for this entry is 412, take away 3242.27, squared divided by 342.27. So you should, what was it, Caleb? 14.2?
Yeah.
14.2 is what it should have been. And that was 2 marks. Okay, and then the last bit, part D, complete the significance test for 6 marks. Why is, so I want to point out, do you see how they've done most of the work here? You've literally got all the chi-square values there. They're all done for you, it's easy from this point. It's still 6 marks. So don't lose marks by throwing them away, by not doing things. So state explicitly, degrees of freedom is this, critical value is this. So, and it also says, what's it missing that it hasn't mentioned? It says complete a significance test, that's unusual, isn't it? Doesn't give you a significance level. So you assume it's 5%, yeah. So that's why it's 6 marks. You have to state assume 5%. Unless there's something obvious in the question that I'm missing. No. So there are your chi-square values. Then this is the only ones you need. So S was 14.2. say you needed to go on the hour?
Oh yeah.
It's like 2 minutes too.
I'll finish this up and then I'll go.
So I know I said we'd have one more lesson on stats, but I don't see the point of starting mechanics. Oh, actually, I don't know, we could. I'm debating doing one more lesson on this. I don't know. I'll think about it.
If you went whiz through mechanics, or you never like extending things.
I worked it out. We've got 10 teaching weeks before the exam starts to do it. So if you look at how fast we did pure, so we finished pure 16th of November. So we did pure in 2.5 months, 10 weeks. We've done statistics, so started statistics then. So we had 4 weeks before, 3 weeks before half term, and then we've had 7 weeks here. So we did statistics in 5 weeks into this one, right? So we did statistics in 8 weeks. So we've got 10 weeks to do mechanics, and then we'll have 2 weeks of revision. That's the plan. And then with the exams, I don't know what dates that the normal A-level maths are. I don't remember them off the top of my head, but I know the further ones are 12th, the 16th, the 20th. So we've got 4 days in between each. Do any of you remember what the days are for the year 12 ones? Year 13 ones are quite late, aren't they? Yeah.
All I know is I've got stats and something else on the same day. That's
Oh,
gonna
God, yeah.
be painful.
Yeah. Yeah. If anyone can do it, shoot. So, don't worry about it. No problem. See you next week. Right, so let's conclude. So, anybody want to tell me what the chi-square values add up to?
Is it 302.89?
I get 302.90, yeah. Did we get that?
Yeah.
Okay, good. So, what was our critical value? 7.815 with 3 degrees of freedom. And can we reject H naught? Our value is greater than the chi-square value, right? So we can reject H naught, yeah. And then you need to state a conclusion of there is something along the lines of that they're not independent. So here's the mark scheme for part D. So the way the 6 marks are given out, you're given one of the marks for stating that there's 3 degrees of freedom. The second mark then is for stating your critical value at 5%. And then there's 2 marks for adding and then getting to the total chi-square value. 1 mark for comparing the chi-square values and correctly rejecting H naught. And then the final mark is an E mark, which is an explanation. So there is strong evidence to suggest that social media usage is not independent of age. And I should be clear here, you should try and be contextual. So don't just say 2 variables are independent, say what they are, if that makes sense. Right. If you want, I don't mind doing 1 more if you want to, or you can go, it's up to you. I give you the choice. If you want to go, there's absolutely no, I won't judge you. You're absolutely welcome to. Right, so if you want to stick around. Oh, but that's not a 2-way table, and that's actually one of the harder ones I've seen. I don't want to do that yet. Yeah, here we go. Spearman's rank, and then that's chi. Okay, so that's chi-square goodness of fit. So this one here is they're testing if a binomial distribution fits, which is what we did yesterday. We'll come back to that. I might have another lesson where we just do it all in one. Right, this is the one that's, so this is what I mean, right? So do you notice that there's a chi-square test here that's literally, so this entire question is worth 12 marks for a chi-square test, yeah? Following question is another chi-square test for a combined what? So combined 1, 2, 3, 4, 5, 6, 7, 8 marks. So 20 marks back to back on chi-square. It's important to be able to do it well. Right, so a student considering options for the future collects data on education and salaries. The sample below shows the highest level of education attained and the salary bracket of a random sample. So by conducting a chi-square test for independence, the student investigates the relationship between the highest level of education obtained and the salary earned. So again, 1 mark, state the alternative and null hypothesis. So null hypothesis being that income and academic attainment or education level are independent. H one being that they are not independent. Okay, so part B, table shows the expected value, calculate the value for K, the expected value for K. So the top left entry, so that they've even shaded it for you, which is quite nice. So can you find that expected value now, please, for this entry here? So you don't actually use the 18 in it, but you are going to use the row and columns. Okay, so I don't know why I'm labelling that so much. I was just kind of sat there, but yeah, it's just literally times and two numbers together. So what, 108 times 71 divided by 664, so I get it to be 11.55. Yeah, good. Okay, so that's K done for 2 marks. So the following computer output is obtained. Calculate the values of M and N. So, okay, so M and N are. So can we make a mental note of what we did? So GCSE, less than 20,000. So 5 or more GCSEs, less than 20,000. And then it's the bottom right. So what I will do, I will make it, I know what I can do. Alright, so. No, it's just chi-square. So to be clear, this is the chi-square table, right? So you're finding the chi-square values. So the ones it wants are the bottom right and this one here. So the one I've highlighted and the bottom right. So to be clear, the bottom right is this 5. Is the bottom right 664? No, that's the total. So this one here.
5.
This one here. So 32 and 24.223. So do that one first and then do the next. Actually, you got it over there, you can. So it's that one and the bottom right. Sorry, I should just, it's a nuisance because they've done it on 2 separate pages. So there are 2, so 32 minus 24.23 squared divided by 24.23. Okay, so do we get the first one to be 2.49?
Yeah.
Okay, good. And then can you do the one at the bottom right then, please? So this one here with this 5 is. Okay, so did we get the bottom right chi-square value to be 1.92? Yeah?
I do.
I didn't do it, okay. Okay, but regardless, do we see that they're going to give you 3 tables and you're going to have to find some missing values, you don't have to find all of them. Right, so the next bit then, without carrying out any further calculations, explain how chi-squared equal 19.61 was calculated. So how was this test statistic calculated? Just explain for 1 mark how they got this.
Everything's up.
They literally add all these up. That's literally what they're going to say, add them all up. And then part 2, so comment on the values in the fewer than 5 GCSE column in the table in part C. Column of the table in part C, so part C, okay, so part C being here. So comment on the fewer than 5 GCSEs one. Okay, so what's our comments? So do you notice that a lot of the values in the table are really low?
Yeah.
Where are the biggest values in the table?
In the field.
In the fewer than 5 GCSEs one, yeah.
Mhm.
So if we are going to prove that they are independent, which of the data is most troublesome? The fewer than 5. Yeah, it's where the most error is. Yeah. So this is where it deviates from the expected value the most with the fewer than 5. So again, that's a statistics common sense question. You expect to just look at it. See, in this column, it's where all the big values are, except for the 20 to 60,000. In which, yeah, so
Because big is then rejected.
yeah, so the way I would look at it, there's a range, people with fewer than 5 GCSEs can range quite a bit, essentially, but other people are a bit more consistent. So without carrying out any guessing, the student says that the highest level of education leads to highest paying jobs. Comment on the accuracy of the student's statement. So the way you would do that is by using this statistic. So this is the chi-square value. Degrees of freedom was 8. So essentially, would it pass the independence test? That's essentially what it's asking you to do. Look at the test. I'll leave it there because I don't want to keep it any longer. But I should point out. So if I look at the stats paper really quickly, can we do this? Random variable has a binomial of this, and a Poisson distribution would mean 4. Calculate e of xy. So can we calculate e of x, e of y, times them together? Yeah. Can we calculate the variance of xy? So that would be a bit more involved, but we have done a lesson on that. What's this?
CPF.
That is a CDF, yeah. And then calculating the upper quartile, finding the mean would be e of x. Find the PDF by differentiating. And then this one here. This is a contextual PDF. We haven't done this yet, but this is a contextual PDF. I just want to do it next time. It's easy. This here is a Spearman rank. Have we done Spearman rank? And have we done the hypothesis test for Spearman rank? Yeah. Then we have a statistics common sense question. The next thing then, chi-square goodness of fit. So what we did yesterday. So here is the number of policies sold. So essentially, a woman, she visits houses and she records the number of policies she sells over different days. So there were 2 days where she sold no policies, 2 days where she sold 1, and so on. She sees the same fixed number of primes each day, and she'd like to know whether the binomial distribution with parameters 6, 0.6 is a suitable model. So the hypothesis would be that H0 data is modeled by binomial 6, 0.6, H1 is not. Conduct chi-square goodness of fit test. So calculate the values of D and E. So how did we calculate the expected values yesterday?
Observed table.
No, it's not a two-way table. So it's
binomials.
so we use binomial probability 3, and we times it by the total. So the total was 50 days.
Yeah.
And then binomial probability 4 times it by 50 days. And then carry out a test at the 10% significance level for 10 marks, by the way. And then chi-square again, and linear regression. So we've done most of this now. I think, would you agree we're in a position now where we've covered pretty much everything that's on there? Yeah. So we'll do contextual PDFs next lesson, and that'll be the end of stats. Right. I'm going to move now though. Thank you all for staying. I appreciate you coming on Wednesday. I know it's a bit of an ask, but I'm grateful.